It is now 1100 UTC, and we can start this webinar. Good morning, good afternoon, good evening, everyone, and even a good night. Some of you are coming very far away, I can see. It's great to have all of you here from different time zones. I see a lot of familiar names, but also quite a few new names. So very welcome to you all. This webinar is being recorded and will be made available on the Ayala YouTube channel later today. So if you have colleagues that missed the opportunity of being here online, they can find the recording on the Ayala YouTube channel. I must ask you all to mute your microphones and switch off your cameras to avoid interruption of the speakers and conserve bandwidth. You can post questions in the chat box area during the presentations, and we will attend to these at the end of the webinar. So my name is Omar Fritz Eriksson, and I am the Deputy Secretary General of Ayala, as well as the Dean of the Ayala Worldwide Academy. I welcome you all to this webinar, which is a part of a series of webinars designed to inform a wider audience on the most recent outcomes of the work of our 4 technical committees. The committees have a 4-year work cycle where they put a lot of effort into developing standards, recommendations, guidelines, and other documents, which then are published and made available as guidance worldwide. Could I ask you to switch off your camera, please? I can't see who it is, but so recommendations tell us what one should be doing when providing marine aids to navigation services, and guidelines tell us how to go about it, and they describe best practices worldwide. Once the committees have developed a document, it is submitted to our council for approval. And once the council has approved the document, it is published and made available to the world through our website. Today, we will present to you the G1165, Guideline 1165 on sustainable structural design of marine aids to navigation, which was approved by our council in December 2021, last December. The need for providing guidance on how to design Aton structures became very clear to me when I visited the Marine Safety Authority of Fiji, MSAF, a few years ago. This was a couple of years after the devastating tropical cyclone Winston had blown away a number of aids to navigation structures back in 2016. The story they told me was that some of the structures had been re-established swiftly, but that these new structures then had been destroyed by another cyclone the following year. So this made me realize that the design codes that were being used for such aids to navigation structures were insufficient and not fit for purpose in an environment with regular cyclones passing by and getting more and more severe with global warming and what have you. So in response to this challenge, we decided to develop some Ayala guidance on how to go about designing such structures in a sustainable manner, and how to go about selecting the construction codes that were more fit for purpose, and would make such structures able to withstand the forces of nature in a given environment. So we took this to the engineering committee, and we received great response from the engineering committee, and I am very happy to share the results of their deliberations with you here today. Today we have 3 speakers with us who will enlighten us on this topic. And the first speaker is Sarah Robinson, who is a maritime and construction consultant with Hawks Hill Consulting Limited, and is also an advisor to the Ayala Worldwide Academy. Sarah is a chartered civil engineer who has previously worked managing terrestrial and maritime assets at the Port of London Authority and as a flood defense project engineer at the Thames Flood Barrier in London. The second speaker is Mr. Jeet Palji, who is a chief specialist in the Waterways Department of Estonian Transport Administration. Jeet started working with the Estonian Maritime Administration in 1998, just after graduating Maritime College as a hydrographer. And in the aids to navigation department, he managed floating aids to navigation and floating and fixed aids to navigation, and was heavily involved in the validation of data, including positioning information following the independence of Estonia from the Soviet Union. It has also been working with differential GPS, and for the last 3 years he has been working in the Waterways Department, mainly on projects concerning the design of waterways. Jeet is a participant in the engineering committee. And our third and final speaker is Mr. Adam Hai. Adam is the founder and director of MNav Solutions, which is a company providing marine aids to navigation products, services, and solutions. Adam has worked extensively in the Asia-Pacific region and is a long-time participant in the Ayala Engineering Committee. All three speakers have contributed to the development of G1165 and are very knowledgeable about the background and everything. And with this, I would like to give the floor to the first speaker, Sarah. Sarah Robinson, the floor is yours.
Thank you.
Take it away. You muted yourself.
Can you hear me now?
Yes.
Okay,
everything
that's a good
is good.
start.
Yeah.
Thank you. Okay, I'm just going to share my screen. Okay.
All good. We can see your screen.
Yeah, you can see my screen. Great. Okay. So just to kick off, I'll just talk for a few minutes in general about the purpose and the scope of the new guideline G1165. So as Omar laid out the background, the Worldwide Academy brought a first draft of the document to the Eng Committee Working Group 2, also with external review by Nanis Kabakoro, who's an engineer from the Asia Pacific branch of Cardno Engineering, as an independent engineer to give an objective view of the first draft. So the draft was then worked on and refined by the Guideline Task Group, which was excellently chaired by Adam, one of the speakers today, and also included Teet, the other speaker, Owen Lehan from Irish Lights, Greg Hansen from AMSA, Teet's colleague, Larry Tumist, and also colleagues from China MSA and myself. And we worked on that at the last committee last year, and that was published in December. And here's our usual suspects rogue gallery of the Eng committee there. So just to give you some background to what the purpose of the guideline is. So the use of the word sustainable in the title of the guideline is the consideration that we give to the balance of cost of design and construction versus the durability, design life, and the associated environmental impact of providing the Aton. So, for example, is it better to spend more initially on a structure that will potentially last longer with appropriate maintenance, or spend less initially and accept that we may have to replace the structure 2 or 3 times over the equivalent design life, as Omar mentioned in the Southern Pacific region that he had experience of. And both of those options have a whole life environmental impact. So to sustainably design an Aton that will last for the length of time we require and under our anticipated environmental conditions, we must ensure that the design is undertaken using design standards appropriate for the geographical location. So this includes anticipated environmental loadings such as wind and wave, and a statement of the level of loading that the Aton should endure. So the guideline's main purpose is to provide guidance to Aton professionals and managers who may not be from a structural or civil engineering background, and to give them confidence to ask relevant questions about the suitability of the design of fixed Aton for the location and the environment. So that the document specifically conveys the importance of structural design that reflects the geographical location and environmental conditions, that where at all possible, the design and assessment of structures should be by appropriately qualified engineers and professionals. The document stresses the value of providing clear requirements to the designer, and also helps, hopefully, the Aton manager or Aton professionals understand what the designer should provide. Hopefully also it will give Aton designers and suppliers confidence in the understanding of the Aton managers, so that they would be dealing with perhaps a more informed client. So the guideline scope, what's covered within the guideline is a brief introduction to the concepts of structural design or assessment. So that would be typical structural elements of fixed Aton that require design, the typical loads that those elements are subject to, and the effects of loading on the elements. The document also covers generic design standards that are typically used in the structural design or assessment of fixed Aton, and it covers non-structural design considerations such as the durability of materials, the sustainability questions that I mentioned previously, and safety. There's also quite a bit of information about the basis of design, and that is the design information document that the Aton manager can expect to receive from the designer. And this principle of designing for the relevant environmental conditions, that applies also to the design of off-the-shelf products, such as, say, prefabricated beacons, as well as structures that require more specific bespoke design. So that's what's covered in the guideline. What is not covered is detailed structural design calculations, as we've mentioned, that there are so many potential design calculations, it would be just impossible really to try and combine them into one document, and because they're regularly updated, that would be a really difficult thing to do. So it doesn't include detailed design. It also doesn't include information that's more than adequately covered elsewhere in other sort of excellent IALA publications, so that it doesn't include floating Aton, inspection and maintenance, for example, or light requirements, because all of those are, there are existing guidelines and recommendations that covers that. But what the document does do is act as a signpost to other IALA complementary publications and external information sources. And it's also maybe worth mentioning at this point that there's another guideline that's been developed by the IALA Eng Committee, Working Group 2, led by Jorg, Peter and Mariano, on the effects of extreme environmental conditions on Aton equipment and structures. So that document is looking at the impact and potential solutions for the effect of heat, cold, water, wind on the durability of Aton. So this developing guideline and G1165 will ultimately complement one another very well. So look out for that over the next 18 months. So that was just my brief introduction to the background, the scope, and the purpose of the guidelines. So now I think what I'll do is hand over to Tiit to give some interesting examples of Estonian fixed Aton and his experience in managing those.
Hello to everyone, and I'll try to share my screen also. Start the presentation. Can you see it?
All good, yes.
Okay, then I start. As was already said, my name is Tiit Palgi, and I am working in Estonian Transport Administration. Previously, it was called Maritime Administration. Estonia is almost surrounded from the sea from all the sides, There is additionally one big lake on the eastern side near Russia, which is also navigable. Naturally, we have quite long maritime history, which starts with our own Vikings. We don't have knowledge of Athens from that area. The history of Athens in Estonia starts considerably later and is reflected in our mix of different Athens. Nowadays, there is 321 fixed Athens in Estonia. And the first hard evidence of the Athens is from medieval period when Germans ruled us. Following Athens from the time of Russian Tsars. And then Estonian Republic emerged. Those are the Athens from the Estonian Republic, which was before the World War II. And then the Athens made at the time of Soviet Union, when the military was held responsible for making sure that anybody suspicious can't get in or out from that state. At Soviet times, standardized fixed Athens emerged, like this, which was often used at the piers. Bigger ones were used in case of leading lines and as orientational marks. And some were quite big, reaching the height of 40 meters from the base. Nowadays, we are mostly renovating old structures or building new ones when the cost of renovation would be too high and structures does not have any historical value. Nowadays, we prefer constructions made of pipes because there is less places where water could collect and cause corrosion. Additionally, it is simpler to assemble the construction, weld and paint it. Sometimes everything doesn't go so smoothly. Here, the bolted connection failed and we started to use bolts through the addition of planes, which is shown on the left side. If we look back, then there is also, you can see the outer flange here, which is bolted. Sector lights are quite complicated systems because care should be taken to avoid reflections at the lantern room. Old lantern room had tilted windows to avoid such a problem. Nowadays, we use sector lanterns, which consists of separate modules. Those pictures on the right side is made from another lighthouse, but I hope you catch the idea. At simpler cases, our own people are replacing dayboards. This mark is situating in the center of the town, Port Pärnu, and the dayboards are facing southwest direction. The problem was that the color didn't last for a long time on those dayboards, so we decided to have a bit different approach, and instead of the paint, we wanted to use some kind of film. The film needs smooth base to make good bond. Usually they are meant to be glued on metals. We are having some marks with metal dayboards. Some painted, but some cases the retro-reflecting film was used, like on the picture at the left. The film had been in place when we was thinking about using film on that mark already 13 years. Differently from previous experience, as shown on the picture right bottom, we decided to use rectangular profile, aluminium profile. Here is aluminium, painted aluminium and wood used. But this wood didn't live so long time. Soon we discovered that the aluminium is quite light and easy to use. Drawback was the designing and preparation process needed to be quite long because we had to carefully measure the construction in order to prepare all the boards. At the site we had just to bolt the boards. This day board, which you see on the picture, took us a bit more than half a day to put on place. As it turned out that this kind of aluminium construction is quite easy to handle with just a manpower, we decided to build 2 times bigger one. And this left picture, you can see bolts attached on the vertical bar of the day board. When we assembled this board, we lifted it up on the tower, and then we just had to bolt everything else. Here is shown front mark before and after renovation of the day board. That's all from me. Thank you for listening. This is my usual work. You can see me on the yellow costume to measure the position of the Aton. Thank you.
Thank you, Teeth. That's fabulous and really interesting to see how you select the materials and change the design to make your Aton more durable. So what I'll do now, if I can share my screen again, is just briefly talk through the, you can see my screen now, hopefully, just briefly talk through the content of G1165. I'll just talk through the main sections. So firstly, section 4 is the first main section in the document, and that provides a summary in figure 1 of the typical design process. So that includes the stages as you work through a typical fixed Aton design. So that starts with the Aton manager's requirements, such as the focal height of the light, the design life, the materials. It then moves on to look at the design codes that are used. So that might be loading, structural analysis, safety and durability. It discusses the basis of design, that document that's the restatement by the designer of the Aton manager's requirements with additional confirmation of the design codes and the criteria that have been used. And then there will be a design output. So what documents can the Aton manager expect to receive from the designer? And finally, there's a brief reference to the construction codes. So it's important to ensure that your Aton is built as intended as well as designed, and with any product or works that you receive, that it meets the requirements before you accept it and sign it off as fit for purpose. So that's section 4. Section 5 covers the Aton manager's requirements in a bit more detail, and it discusses the importance of the Aton professional providing clear specification and where you might get assistance if you're not actually quite sure what information you need to provide. So it covers that detail, and table 1 in section 5 suggests typical requirements that the Aton manager might specify. A fundamental functional requirement for Aton is height, either as a support for a light or a signal transmitter, and the height therefore affects the foundation, complexity and size. And the document also discusses that how important the quality of the design and the requirements are in influencing the reliability and therefore the availability of the Aton as a whole. Section 6 looks at typical elements of fixed Aton structures that might require design irrespective of the location. And elements are typically assessed on a combination of the part they play in the structural integrity and the material that they're made of. So, for example, structural steel, reinforced concrete, foundations. And the document also talks about how protective coatings are also an important consideration when you're deciding on materials and in the design specification. So section 6 continues with describing typical loads experienced by fixed Aton, and then section 7 looks at globally generic design standards. So whichever region of the world you're in, there is usually design standard based on these generic areas of design, such as the principles of design, loading, structural steelwork, piling, timber, etc. And the design standards also apply to the assessment of existing structures. Something that the document stresses is the importance to consider the concept of annual exceedance probability, which you can read more about in the document, but that's a way of describing the level of environmental conditions we want the structure to withstand, as that will affect the cost and the probability of the structure failing or not. Section 8 briefly covers additional design considerations that can influence the preferred design option. So that might be durability. So the deterioration of material can lead to a loss of load-bearing capacity, for example. It considers sustainability, that the discussion we mentioned before. What is the whole life cost approach? Do we want to design for an average year weather-wise or an extreme year? Is it more cost effective longer term to build a more robust structure rather than risk replacing a cheaper structure once or even twice over the same design life? The document looks at waste reduction and waste management through the design. It considers stakeholder requirements because they can also influence access and operation. Can the structure be accessed and maintained safely? And similarly, how does the design allow or minimize the potential for trespassing, theft and vandalism? Finally, section 9 briefly describes the potential design output that the Aton manager might receive from the designer. So that might be specifications and drawings that a contractor or a supplier can use to provide the Aton. There may be operational manuals to help through the operation of the structure. There might also be a designer's risk assessment. And then there might also be the basis, or there should be a basis of design summary document. And that's this document, a really important one that summarizes what the original requirements were, and then what additional standards, references, design parameters and values the designer has used when designing the Aton. So therefore, that document is a great opportunity for the Aton manager to check and compare what the design has provided with the original requirements, and also an opportunity to challenge the designer if there are items missing, perhaps using G1165 to help you. And an example basis of design document is provided in Appendix 1 of the guideline. So that was a very quick summary of the guideline content, but it basically covers providing the Aton manager or professional with a basic level of understanding about the structural principles of Aton design, the typical design process, and the documents that they may expect to receive from the designer. So I'm going to hand over to Adam now, and then I'll be back after Adam shows us some really interesting case studies from his experience. I'll talk about the production of regional information based on the general principle of the G1165 document.
Thanks, Sarah. I'll try and share my screen. Can you see that?
Yeah, we can see it. Yep.
Okay. Yeah. Good evening or good morning, everybody. Depends what part of the world you're in. So I'm going to give a quick presentation with lots of photos based on some case studies on structure replacements. I'm going to cover two different case studies, which are both from Papua New Guinea. One is for a place called Stratford Island, and another one is for a location called Delman Front Lead. So the first case study is on a location called Stratford Island, which is, as I said, it's in Papua New Guinea, which is in the Pacific. This particular site on the right, you can see the photo. This was a Category 2 Aton. The original structure was a 20-metre GRP tower with the 10 nautical mile range. And then this marks the northern tip of a group of uninhabited islands which are directly adjacent to one of the main international shipping channels that run through PNG coastal waters just north of the Joe Mud entrance. So the majority of international vessel traffic passes fairly close to these islands. This is just an AIS density plot of the shipping channel. You can see at the bottom where it converges into PNG waters. And this particular spot is located here, where the shipping channel splits. So the initial structure that was installed, this was done in 2005. It was done to replace an old steel lattice tower that had been there for about 20 years and had deteriorated until collapse. At the time of this job, I was working on the contractor's side, and this particular structure was specified in the contract documentation. It was located as far away from the coastline as we could to avoid the erosion that was evident on the old structure, which the foundation could be seen on the beach. It was quite a big engineered concrete foundation. And at the time that we installed it, it was quite a stable shoreline with probably about 20 metres to the coastline. Probably about 5 or 6 years after, we started to notice increasing erosion. There was a 6-month scheduled visit to each of these sites, and it was quite evident that this was caused by Longshore Drift, which was just the seasonal movement of beach rubble and that erosion and accretion cycle. So the beach was going back and forth. It was building up and it was eroding during the natural cycle. But what we noticed was happening was that the edge of that concrete foundation started interfering with that natural cycle. So as the beach eroded at a certain time of the year, the concrete foundation was causing some issues. It got to the point where we were noticing increased risk of collapse or failure, which is, of course increases the risk of potential shipping incidents due to its location. This was a photo very early on, so you can see the amount of shoreline that was available at that time. You can see the old concrete foundation at one of the legs in front, the rest had been washed away. And this was how close the shoreline was getting a couple of years later. I'm going to follow up with a couple of just full screen photos to show you how bad it got. This was initially probably a couple of years after installation. This was probably a year after. And you can start seeing how severe that erosion was getting. Again, this was just natural longshore drift, but that concrete foundation was causing issues with the beach hydrology. You can see eventually getting to the point where that foundation is getting ready to collapse. So we were asked to go through the replacement process because of the level of risk of failure was deemed too high. You can see that photo on the right again. The NMSA required a proposal for a replacement structure, and they wanted the lessons learnt to be applied to not make this same mistake of an onshore structure in the wrong position. We didn't have the time to do a detailed longshore drift study. So it was not possible at that stage to actually predict the future sediment movement and the shoreline changes, especially with that foundation now there on site. So it required, and this is part of this new guideline, and as Sarah said earlier, it required a balance of cost and assured reliability, availability. So we had to look at it from several angles. So when we started looking at structure selection, we automatically deemed that shore-based Aton was not going to be suitable due to the concerns over the beach stability and, you know, ongoing environmental impact of having these concrete foundations in situ. Now, the main shipping risk, the main hazard this was marking, the shipping channel was west of the island. When we looked at the surveys, there was an extended reef platform to the west, which was of a suitable depth to install a fixed piled Aton. We had some concerns over the focal height and its impacts on range. So we did a very quick, just a geographical range analysis to confirm the suitability that we were going to get the range at the height that we could achieve with the piled Aton, which worked out okay. There was a slight change in the arc of visibility due to the island obstructing the light to the east, but there's very little shipping to the east of the island, so it was also deemed acceptable. So on the right is a photo of the structure that was eventually installed. Piled Aton was chosen. These are used extensively in PNG coastal waters for very similar scenarios. They're a very durable structure. It helped standardise the NMSA's assets. It places the Aton closer to the shipping lane. And as it was an existing design that had been designed quite thoroughly, a lot of work can be done, and it was very easily adjusted to suit the site conditions. So we did undertake a design review process and considered all of the conditions. Sarah mentioned quite a few of these when she introduced the guideline. So we took into account the wind loads, the waves, currents, depths, the corrosion loss in the pile column, the ultimate bending moment, and these were all used to basically come up with the correct specifications for that particular structure. So in the end, we are able to achieve an 8-metre focal height, which was a lot less than what we were achieving on the island, but was still sufficient to achieve the range that we needed to get for the shipping channel. It was 814mm monopile, quite exposed conditions, so it had to be quite a sizable pile column. These were driven in 4 metres of depth, 8 metres of seabed penetration. We were able to apply quite a few different corrosion protection systems. We had sacrificial anodes. You can see one of those in that bottom left-hand photo. We had a Denso system and a marine epoxy coating on the steel pile. We were also able to use marine-grade stainless steel fittings basically on everything that was exposed, including the driving tongue, the ladders, and the fittings for the lantern and solar panels. And basically the design life of this structure is 30 years. Of course, you have some maintenance on things like the Denso and a bit of touch-up painting, but they're quite a durable structure. The other thing with these structures is they have minimal environmental impact, and we actually found them over time to be habitat enhancing because, as you can see in that bottom photo, they're a fixed pile in the seabed and they actually encourage marine growth. So that was case study 1. Case study 2 is similar but different. This is on a site called the Delman Front Lead, again in Papua New Guinea. Now this was a category 1 Aton. There was probably only about 10 of them in Papua New Guinea at that time, so there was only a handful deemed to be vital. This was a steel structure on a concrete foundation with the daymark board. So the photo there is the front lead. The rear lead is back amongst the palm trees. This had a range of 6 nautical miles, and this was to market transit through a very narrow entrance into a place called Madang Harbour, which had a complex mix of vessel traffic, anywhere from fuel tankers to coastal traders, tourist vessels and small craft. That's just a photo there of where the the little place marks where the lead was located, and that arrow shows the channel. And the right-hand side is just a density plot showing how much traffic actually channels into that harbour. So the issue we had on this site, and this was a much older site, it was about 15 years old. We noticed increased erosion during these scheduled maintenance visits. Now, this was quite different to the other site. This wasn't caused by Longshore Drift. This was quite a stable coastline, but wind and wave action, exposed nature of the shoreline, it was just washing away. There was also a lot of propeller wash and wash from passing small craft. The edge of the concrete foundation eventually became visible, and eventually it got to the point where the structure started leaning, which was affecting the performance and reliability of those leads to provide safe transit. So as that front lead dipped, it was impacting how mariners could view those leads in their transit. Again, there was an increased risk of structural failure and shipping incidents. So this is a few photos of how bad it actually got. As I said, this was several years, but several years like this, it was quite a stable shoreline, but it was just slowly eroding away. The photo on the right is eventually when it was decided we needed to take action because it started collapsing quite slowly. So the leaning of the structure required an immediate response because it was Category 1 Aton, marking a very important entrance. There was very limited space available between the rear and the front lead for repositioning. There was also a lot of local landowner issues, which anybody that's listening here from the Pacific will understand that, but there was issues to secure land for the new site. It was possible to stabilise the shoreline, but it was prohibitively costly. It would have been quite an expensive construction job to stabilise that shoreline properly, which just wasn't worth it. Again, there was an extended reef platform in front of this site, went out about 30 metres, which also had caused some incidents for small craft passing into town past the site. So on an analysis of all those, we deemed that shore-based Aton was unsuitable due to the space on site and access to the land. We looked at moving it onto the edge of the reef platform, which you can see there. We located and identified a location approximately 28 metres from the current position. That increased the distance between the front and rear lead by 25%. So we carried out some lead calculations just to confirm it was still suitable and to confirm the height of the new structure. After our calculations, we identified there was no change to the performance of the transit, but it also just helped to mark a hazard for small craft passing the site. When I say small craft, I mean small outboard-driven dinghy motors that can go quite shallow. So in the end, again, we moved to a piled Aton. Again, as I said, it was used extensively in coastal waters in PNG for similar scenarios. Doesn't affect the performance of the front or the rear lead because we can basically get whatever height we needed. Existing design, easily adjusted to suit site conditions. As I said in the last case study, we did the same review process: wind loads, waves, currents, depths, looked at corrosion loss and the ultimate bending moment to pick the monopole. We went with a 7-metre focal height, which matched the old structure. Again, an 840mm monopole, depth of 4 metres, 7-metre seabed penetration. We had the same corrosion protection as the case study 1. We utilised stainless steel for all fittings, including the Daymark board. Again, design life of pole of 30 years, and you can see the photo on the left. That was as installed straight into a coral reef. We have all the environmental protections for the process, but you can see very little environmental impact over the lifespan of the structure. And that is a photo looking back from the shoreline straight out the entrance. And that is the end of my presentation. Hope you enjoyed. Thank you.
Thanks very much, Adam. That's it's so interesting how those case studies demonstrate the balance that you have to achieve of the design considerations of like Aton function, durability, navigational risk, and the environment. So they're really interesting. Thank you.
Thank you.
So I'm just going to share my screen for one last time. And I'm just going to talk through the regional supplementary guides that we're currently producing to accompany Guideline G1165. So having produced the guideline, the generic guideline, the IALA Worldwide Academy were very keen to provide regional-based guidance, as described by Omar in the introduction. That was the main motivation. So we've initially produced a document, a PDF that can be downloaded, or it can be actually printed and folded like a leaflet if necessary. And we've produced one initially for the Southern Pacific Islands with assistance from our colleagues in Fiji, Nauru and Australia. And the purpose of these supplementary guides is to give more detailed regional information on typical environmental loading considerations, sources of regional environmental data, and also typical specific design standards used in the region. So let's just have a quick look at the. Okay, great. So this is the PDF of the supplementary guidance, and it's, let me just, you can see it's this sort of 6-page folding shape that folds into a leaflet. The first page, this is the first page, obviously, is for the Southern Pacific Islands, and then page 2, which is over here, that discusses and provides particular regional environmental loads. So as well as the standard loads of the dead weight of the structure or the live weight of the personnel walking on the structure, there is this third category of environmental loads, and this information provides more guidance on the kinds of environmental loads that might be experienced in the region. So for example, seasonal increased wave height or seismic activity. Then on page 3, we go on to talk about typical regional design standards. And again, let me see if I can just zoom in a little bit. We've produced two diagrams, one a terrestrial or land-based typical Aton design, and one for marine-based Aton. And what that does is give further detail on the typical specific design codes that might be used for the design of Aton in this particular region. So for example, the dead and live loads, including wind, the joint Australian-New Zealand standard 1170 would be used. For steel fabrication and construction, the joint standard 5131 would be used. So that is just to try and put a bit more detail for regions on the kinds of standards that might be used in design, and for the Southern Pacific region, you'll know if you look through this that they tend to be either Australian or New Zealand design codes. So the leaflet covers the specific typical design standards used, and then also provides a bit more information on useful regional information sources. So this Pacific Climate Futures website is about regional climate change predictions and how you can undertake design should incorporate the potential for changes in the environmental loadings that Aton might be subject to. So this is the guide. This is the pamphlet for the Southern Pacific Islands. The next one that we're hoping to produce is for the Caribbean region, with assistance from our colleague Julio Fidel in Cuba, who's provided a lot of really helpful information. And that draft will be come in the next month or so. And if anybody who's dialing in today is from the Caribbean region and feels that they might be able to contribute to producing similar diagrams for the Caribbean region, that would be great to have your assistance. And then please also let us know where else in the world should we produce a leaflet for. So we're currently considering the cyclonic zones of the Indian Ocean, perhaps the Western Pacific, Southeast Asia, but really please let the Worldwide Academy know where you think it would be most useful to have this more specific regional design information. Or one other thing, also hot off the press, Minsu forwarded me this document recently published by PIANC that considers the effects of climate change on port infrastructure. And that's quite a recently published guidance. So I think there might be some really useful information in there that you could use to complement G1165 when considering sustainable design. Let me just get rid of that. So finally, what I need to do is just quickly show you where to find this information. Just see if I can get the page. Okay, so obviously G1165 can be found on the IALA website in publications. So that's here, publications, search in publications, and you can just look for G1165 there, like you can for any document. And then the supplementary regional information, this has been given its own web page, and that comes under this again the IALA website, topical matters. So this is this section here, and down at the bottom is the G1165 supplement, and this is the holding page for a link to G1165, and then also the PDF leaflets that I just showed you. So here we have the Southern Pacific Islands, and then we also have coming soon the comparative one for the Caribbean region. So that's just to help you navigate your way around where to find that information. So really that's all the information that we wanted to present formally to you today. And now perhaps I'll hand back to Omar to maybe facilitate discussion or answer any questions.
Excellent.
Thanks, Omar.
Thank you very much, and thank you all speakers for excellent and very clear presentations and quite informative. So the floor is now open for questions. We have time for a few questions, and in the chat we have had two questions. The first one is for Adam. Case study 1, did you do some ship collision assessment? And what was done with the old structure, by the way, Adam?
Yeah, we didn't, Omar, we didn't do any detailed risk assessments. We just had a look at we had the density of traffic that was going past. We had the density plots and a little bit of local knowledge. So we didn't get much deeper than just looking at what was going past and talking to local people. What was the second question? Sorry, the old structure? Yeah,
the old structure. Did you just leave it to fall or what?
No, it was in very good condition. So we removed the old GRP structure and packed it in a container for the authority. But in the end, it was decided not to move the concrete foundation because to break up a 16 cubic metre concrete foundation would have led to a lot of a mess on the island. So it was left there. And we've just kept an eye on it. The beach has not got any worse. It's sort of just becoming part of the beach now.
Okay. So the GRP structure is now available for new Aton projects where they're more suitable.
Correct.
Maybe.
Yeah,
okay.
Exactly. So I think they'll choose the right location next time.
Yeah, coastal erosion is an ongoing problem in many regions of the world. So
yes.
let me see. There's incidentally another question for you, Adam, on the case study 1 in the chat now. How do service personnel safely access the ladder to service the lantern, and what is the control from falling from height? Well, it's a soft fall, I can say, but Adam.
No, I've fallen off one before. No, but it's we have in Papua New Guinea, we've got the added issue of vandalism and theft. So that ladder looks very high, but we had a specially fabricated ladder with hooks that we would come in a small boat and it would hook the ladder up there, attach it to the pole, climb up and put your climbing harness on. We couldn't have a ladder all the way to the seabed because it was just to the sea level, because it just allowed anybody to access the site. So we had to consider those theft preventative measures.
Okay. And then, Sarah, for you, from Ellison Raby, from somewhere, I don't know exactly where, but thanks, Sarah. Thank you for a very clear presentation of the guideline. In section 4, structural analysis codes, what is recommended when the location of the structure is outside the existing design codes, e.g. wave loading on a structure on a wave-washed surface piercing reef, where this is an ongoing research question?
Yes, it is an interesting question, and I think that's maybe a specific example for a general consideration. Alison, I don't know if you're familiar with some of the more marine specific standards, whether there's, hi Alison. Hi. Yeah, whether there's any information that might be available within either the British standard, the 6349, and the PANC guidance, or the equivalent Australian, I think it's 5997 maritime design codes. Have you? Is it that you've looked at that and exhausted the information? Is that why you're considering? You're looking for that guidance, or feel free to unmute and
that gap in the research in the design codes motivated the storm lamp project, which recently finished.
Right.
So I just wondered about where there are gaps in knowledge, where you point people to.
Yeah, and well, maybe that's also a point at which that was one of the reasons for trying to produce the regional design codes. So, for example, in the Southern Pacific, there are some existing research programs to try and give better both current day and predictions for wave loadings, wave heights, and wave combinations. So to answer your question, my personal knowledge doesn't extend to a specific example that I could point you to, but that hopefully the regional guides that we're providing will bring together these regional sources that might fill in some of those gaps that aren't in the more generic guidelines. Okay, thank you.
And indeed, we are very interested in identifying gaps in knowledge and areas where further research is needed, because that's one of the purposes of the Academy, to identify such gaps and try to get some research going into these areas. I've exhausted the questions in the chat, and there's of course a greeting from the Secretary General saying what an excellent presentation this has been, and important as well. But are there any questions from the floor? Anybody that wants to pose a questions to the speakers? You could raise your hand in the reaction section. No, that doesn't seem to be the case, so I will then move on. We still have a couple of minutes left of the allocated time. But so before we close the webinar, I would like to remind you on the Ayala Intergovernmental Project. So in January 2021, the government of France signed the new Convention on the International Organization for Marine Aids to Navigation, which had been under development for the last 10 years, actually. Shortly thereafter, that is after January 2021, a diplomatic note was sent from the French government to 190 ambassadors around the world to invite them to sign this convention on the International Organization for Marine Aids to Navigation. And the timeline for the signature period was 12 months, which closed on the 26th of January this year. On that day, Ayala hosted a signature ceremony at our headquarters in Saint-Germain-en-Laye in France, where coastal states were invited to sign the convention. The ceremony was very well attended, and you can find an Ayala Worldwide Academy news clip from the ceremony on the Ayala website, actually. The end result was that we now have, I think, 52 coastal states signatures on the convention or to the convention. These coastal states will now ratify the convention in their respective parliaments. And when we have 30 ratifications, Ayala will begin its actual transformation from a non-governmental organization to an intergovernmental organization. This can possibly take place within a couple of years, and we look very much forward to this major milestone in the 60 plus years life of our association. Don't worry if your government is not one of the 52 states who have signed the convention at this stage. The signature period has closed, but it is still possible to accede to the convention when your government wishes to do so. So if you need more information on how to do that, please contact the Ayala Secretariat. Meanwhile, one further question has been received. Let me just, this is Randy AR. For case study 1, I've noticed that the previous beacon was higher than the new one. How do you ascertain the sufficient lantern focal height of the new beacon? I think that was addressed in the presentation, but Adam, would you like to repeat that? Just.
Yeah, sure. Yeah, the original site had a 10-mile range, so we moved it out a little bit, of course, but we needed to ensure that we could get 10 nautical miles. So we did a quick study on the geographical range to confirm that we could get 10 nautical miles with a light at that focal height, which was okay. We did lose some height, but we could still get the range.
Yeah, so exactly. And by the way, on the question on collision risk assessment, I would like to remind you that Ayala also has excellent guidance on how to assess risk or the probability and consequences of collisions and groundings in a waterway. We have the so-called Ayala Risk Management Toolbox, and on the website you can find a number of courses that are designed to introduce you to these tools, the tools of the toolbox, and how to assess marine risk, if you will. No further questions raised, so I will now move to the closing of the webinar. So the next webinar is scheduled to happen a few weeks after the next council meeting in June this year. At this webinar, we will present some of the wonderful new publications which the council may or may not or may have approved at its 75th session, which will take place in Copenhagen, actually, in June. So I must thank the presenters, Sarah, Keith, and Adam, for their excellent contributions to this webinar. And I want to thank you also, participants, for showing up. I think I counted 68, which is very well, very good. Well done. And I hope that you have found the information provided interesting and useful, and the time that you spend on this time well spent. I also want to thank the Ayala Secretariat for making this webinar possible. Isabel and Audrey, thank you. And stay still clear of COVID-19 for some time to come. But we hope to see you, those of you that come to Ayala meetings face to face in the autumn. We are getting rid of COVID now, and we want to get physical again. Face-to-face meetings is the future, and you are all welcome to participate in Ayala events, both virtual and physical, of course. So the webinar is hereby closed. Thank you all, and goodbye.
Thank you.